School of Management Studies IGNOU presents an audiobook on the course MMPC 005 Quantitative Analysis for Managerial Applications for MBA program. Block 3 Sampling and Sampling Distributions. Unit 9 Sampling Methods. Part 2.
Stratified sampling. Stratified sampling is more complex than simple random sampling, but where applied properly, stratification can significantly increase the statistical efficiency of sampling. The concept. Suppose we are interested in estimating the demand of non-aerated beverages in a residential colony. We know that the consumption of these beverages has some relationship with the family income and that the families residing in this colony can be classified into three categories, viz. High income, middle income and low income families. If we are doing a sampling study, we would like to make sure that our sample does have some members from each of the three categories, perhaps in the same proportion as the total number of families belonging to that category, in which case we would have used proportional stratified sampling. On the other hand, if we know that the variation in the consumption of these beverages from one family to another is relatively large for the low-income category, whereas there is not much variation in the high-income category, we would perhaps pick up a smaller than proportional sample from the high-income category and a larger than proportional sample from the low-income category. This is what is done in disproportional stratified sampling. The basis for using stratified sampling is the existence of strata such that each stratum is more homogeneous within and markedly different from another stratum. The higher the homogeneity within each stratum, the higher the gain in statistical efficiency due to stratification. What are strata? The strata are so defined that they constitute a partition of the population. That is, they are mutually exclusive and collectively exhaustive. Every element of the population belongs to one stratum and not more than one stratum by definition. A stratum can therefore be conceived of as a subpopulation which is more homogeneous than the complete population. The members of a stratum are similar to each other and are different from the members of another stratum in the characteristics that we are measuring. Proportional stratified sampling. After defining the strata, a simple random sample is picked up from each of the strata. If we want to have a total sample of size 100, this number is allocated to the different strata, either in proportion to the size of the stratum in the population or otherwise. If the different strata have similar variances of the characteristic being measured, then the statistical efficiency will be the highest if the sample sizes for different strata are in the same proportion as the size of the respective stratum in the population. Such a design is called proportional stratified sampling. Disproportional stratified sampling. If the different strata in the population have unequal variances of the characteristic being measured, then the sample size allocation decision should consider the variance as well. It would be logical to have a smaller sample from a stratum where the variance is smaller than from another stratum where the variance is higher. Stratified sampling in practice. Stratification of the population is quite common in managerial applications because it also allows to draw separate conclusions for each stratum. For example, if we are estimating the demand for a non-aerated beverage in a residential colony and have stratified the population based on the family income, then we would have data pertaining to each stratum which might be useful in making many marketing decisions. Stratification requires us to identify the strata such that the intra-stratum differences are as small as possible and inter-strata differences as large as possible. However, whether a stratum is homogeneous or not in the characteristic that we are measuring, for example, consumption of non-aerated beverage in the family in the previous example can be known only at the end of the study, whereas stratification is to be done at the beginning of the study. And that is why some other variable like family income is to be used for stratification. This is based on the implicit assumption that family income and consumption of non-aerated beverages are very closely associated with each other. If this assumption is true, stratification would increase the statistical efficiency of sampling. In many studies, it is not easy to find such associated variables which can be used as the basis for stratification, and then stratification may not help in increasing the statistical efficiency, although the cost of the study goes up due to the additional cost of stratification. Cluster sampling. Let us take up the situation where we are interested in estimating the demand for a non-aerated beverage in a residential colony again. The colony is divided into 11 blocks called Block A through Block K. We might use cluster sampling in this situation by treating each block as a cluster. We will then select 2 blocks out of the 11 blocks at random and then collect information from all families residing in those 2 blocks. Cluster versus stratum. We can now compare cluster sampling with stratified sampling. Stratification is done to make the strata homogeneous within and different from other strata. Clusters, on the other hand, should be heterogeneous within, and the different clusters should be similar to each other. A cluster ideally is a mini population and has all the features of the population. The criterion used for stratification is a variable which is closely associated with the characteristic we are measuring. For example, income level when we are measuring the family consumption of non-aerated beverages in the example quoted earlier. On the other hand, convenience of data collection is usually the basis for cluster definitions. Geographic contiguity is quite often used for cluster definitions, and in such cases, cluster sampling is also known as area sampling. There are very fewer strata and one requires to pick up a random sample from each of the strata for drawing inferences. In cluster sampling, there are many clusters out of which only a few are picked up by random sampling, and then the clusters are completely enumerated. Cluster sampling in practice. Cluster sampling is used primarily because it allows for great economies in data collection cost since the travel-related cost etc. are smaller. Although it is statistically less efficient than simple random sampling in most cases, this deficiency may be more than offset by the high economic efficiency that it offers. For example, to get a certain precision level, one might need a sample size of 100 under simple random sampling and a sample size of 175 under cluster sampling. However, if the cost of data collection is ₹20 under simple random sampling and only ₹5 under cluster sampling, it would be cost effective to use cluster sampling. Cluster sampling is rarely used in single-stage sampling plans. In a national survey, a district might be treated as a cluster, and cluster sampling can be used in the first stage to pick up 15 districts in the country. Some other form of probability sampling like stratified sampling, cluster sampling, etc. is then used to go to a smaller sampling unit. If a frame has to be developed, then cluster sampling allows us to save on the cost of developing a frame because frames need to be developed only for the selected clusters and not for the whole population. Multi-stage and multi-phase sampling. In most large surveys, one uses multi-stage sampling where the sampling unit is something larger than an individual element of the population in all stages but the final. For example, in a national survey on the demand of fertilizers, one might use stratified sampling in the first stage with a district as a sampling unit and the average rainfall in the district as the criterion for stratification. Having obtained 20 districts from this stage, cluster sampling may be used in the second stage to pick up 10 villages in each of the selected districts. Finally, in the third stage, stratified sampling may be used in each village to pick up frames in each of the strata defined with the land holding as the criterion. Multi-phase sampling, on the other hand, is designed to make use of the information collected in one phase to develop a sampling design in a subsequent phase. A study with two phases is often called double sampling. The first phase of the study might reveal a relationship between the family consumption of non-aerated beverages and the family income, and this information would then be used in the second phase to stratify the population with family income as the criterion. Non-probability sampling methods. Probability sampling has some theoretical advantages over non-probability sampling. The bias introduced due to sampling could be completely eliminated, and it is possible to set a confidence interval for the population parameter that is being studied. In spite of these advantages of probability sampling, non-probability sampling is used quite frequently in many sampling surveys. This is so because all are based on practical considerations. Probability sampling requires a list of all the sampling units, and this frame is not available in many situations, nor is it practically feasible to develop a frame of, say, all the households in a city or zone or ward of a city. Sometimes the objective of the study may not be to draw a statistical inference about the population, but to get familiar with extreme cases or other such objectives. In a dealer survey, our objective may be to get familiar with the problems faced by our dealers so that we can take some corrective actions wherever possible. Probability sampling is rigorous, and this rigor, for example, in selecting samples, adds to the cost of the study. And finally, even when we are doing probability sampling, there are chances of deviations from the laid out process, especially where some samples are selected by the interviewers at site, say after reaching a village. Also, some of the sample members may not agree to be interviewed or not available to be interviewed, and our sample may turn out to be a non-probability sample in the strictest sense of the term. Convenience sampling. In this type of non-probability sampling, the choice of the sample is left completely to the convenience of the interviewer. The cost involved in picking up the sample is minimum, and the cost of data collection is also generally low. For example, the interviewer can go to some retail shops and interview some shoppers while studying the demand for non-aerated beverages. However, such samples can suffer from excessive bias from known or unknown sources, and also there is no way that the possible errors can be quantified. Purposive sampling. In convenience sampling, any member of the population can be included in the sample without any restriction. When some restrictions are put on the possible inclusion of a member in the sampling is called purposive. Judgment sampling. In judgment sampling, the judgment or opinion of some experts forms the basis for sample selection. The experts are persons who are believed to have information on the population which can help in giving us better samples. Such sampling is very useful when we want to study rare events, or when members have extreme positions, or even when the objective of the study is to collect a wide cross-section of views from one extreme to the other. Quota sampling. Even when we are using non-probability sampling, we might want our sample to be representative of the population in some defined ways. This is sought to be achieved in quota sampling so that the bias introduced by sampling could be reduced. If in our population 20% of the members belong to the high income group, 30% to the middle income group, and 50% to the low income group, and we are using quota sampling, we would specify that the sample should also contain members in the same proportion as in the population. For example, 20% of the sample members would belong to the high income group, and so on. The criteria used to set quotas could be many. For example, family size could be another criterion, and we can set quotas for families with family size up to 3, between 4 and 5, and above 5. However, if the number of such criteria is large, it becomes difficult to locate sample members stratifying the combination of the criteria. In such cases, the overall relative frequency of each criterion in the sample is matched with the overall relative frequency of the criterion in the population. The sample size. How large a sample should be taken in a study? So far in this unit, we have not addressed ourselves into this question. At this stage, we will only mention some factors that affect the sample size decision, and in later units, some of these ideas will be gone into more depth. One of the most important factors that affect the sample size is the extent of variability in the population. Taking an extreme case, if there is no variability, that is, if all the members of the population are exactly identical, a sample of size 1 is as good as a sample of 100 or any other number. Therefore, the larger the variability, the larger is the sample size required. A second consideration is the confidence in the inference made. That is, the larger the sample size, the higher is the confidence. In many situations, the confidence level is used as the basis to decide sample size, as we will learn in the next unit. In many real-life situations, the factor of overriding importance is the cost of the study, and the problem then becomes one of designing a sampling scheme to achieve the highest statistical efficiency subjected to the budget for the study. It is here that cluster sampling and convenience sampling score over other more statistically efficient methods of sampling, since the unit cost of data collection is lower. Now let's summarize the unit. In this unit, we have learned various sampling methods available when one wants to make some inferences about a population without enumerating it completely. We started by observing some situations where sampling was being done and then found that in many situations, sampling may be the only feasible way of knowing something about the population, either because of the time or cost involved, or because of the physical impossibility or practical infeasibility of observing the complete population. Also, sampling can give us adequate results in many applications and can be preferred over complete enumeration, as it ensures a higher purity of the data collected, especially when the population is large. We noted that there are two basic methods of sampling: probability sampling, which ensures that every member of the population has a calculable non-zero probability getting included in the sample, and non-probability sampling, where there is no such assurance. Probability sampling is theoretically superior to non-probability sampling, as it helps in reducing the bias and also allows us to quantify the possible error involved. But non-probability sampling is less rigorous, easy to use, practically feasible, and gives adequate results in some applications. Among the probability sampling methods, simple random sampling works the best when the population is homogeneous, but may have many practical limitations when the population is large. Simple random sampling ensures that each of the possible samples of a particular size has an equal probability of getting picked up as the sample selected, and it also implies that each element of the population has an equal probability of being included in the sample. Systematic sampling starts with a random start and picking up members after a fixed interval down a list of all members called the sampling frame. If the population can be broken down into smaller, more homogeneous subpopulations or strata, then stratified sampling should be used, which allows higher economic efficiency as the cost of data collection per element is reduced if members are physically or otherwise closer to each other as they are in a cluster. Most large studies are based on multi-stage sampling, where different sampling methods are used at each stage. In some studies, multi-phase sample is also used, especially where the information collected in one phase is used in the sampling design of a later phase. We have also discussed some of the non-probability sampling methods used in practice. If any member of the population could be included in the sample, we would get a convenience sample. On the other hand, if the entry is subjected to the judgment of some expert or experts who have a better knowledge of the population, we would have used judgment sampling, and if the sample is made representative of the population by setting quotas for elements satisfying different criteria, this is called quota sampling. Purposive sampling is a genuine name for all non-probability sampling methods where restrictions are used on entry. We have understood all of these sampling methods to gauge their strengths and weaknesses and also to find their applicability under different conditions.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code MMPC 005, Quantitative Analysis for Managerial Applications. Voiceover by Harpreet Kaur. Edited by Savita. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.